thanks everybody for joining. If you could put in the chat, maybe in the Discord chat, what kind of experience you've had building products with LLMs, that would be great, whether it's LLMs or agents. And then you can do that while I'm introducing and setting the stage here. So I'm pretty excited to have Hugo on. He's been a data and AI consultant, worked with teams and taught teams such as, Netflix, Meta, the Air Force, and as well as startups and really all over. He's hosted the Vanishing Gradients podcast for quite a long time, which is a really nice podcast that covers all kinds of like developments in data science, AI, data in general, evaluations, building LLM applications, building agents, and it's a really nice podcast. One I've followed for quite a long time and listened to and learned from for quite a bit. Um, I'm particularly excited about Hugo being here because he is someone that I've followed for quite a long time. I've learned from a lot of his content, and I'd never actually like collaborated or worked on anything directly with him, which is why I'm super excited to be doing this now because I've gotten so much value out of his content before, and now I get to work with him. So it's super exciting. So I'll turn it over to you, Hugo. Just kind of see if anyone put in the chat with what kind of experience building they have. All right,
So,
not yet.
but I can ask a question. Firstly, thanks so much for the generous invitation to come and chat here, Isaac, and for the lovely introduction. And that's right, we hadn't connected until recently. And it was actually our mutual friend and colleague, Hamel, who connected us, who's a wonderful node in the network. It's great to see a bunch of people who I know here. Julian, it's always a pleasure to see you as well. I would love to know. So this course Isaac and Eleanor have been teaching is about using AI to help you write software, right? Which is very different to using AI in your software, such as pinging LLM APIs, doing retrieval, building agents, that type of stuff. So I'm wondering in Zoom, if you would just put your hand up if you've used LLMs in software, like pinging APIs and feeding that into your software. We have one. I'm pretty sure Julian has. I mean, because he took my course. So, okay, cool. Has anyone built something like RAG or something agentic or anything along those lines? Okay, we have one or two people as well. Well, this is super exciting because these are the types of things we'll be talking about today. How we think about building these things, but also how we think about using them. So without further ado, I'm going to share my screen. Can you see my screen, Isaac?
Yep, we can see it.
I'm going to maximize. So I want to talk about how I learned to stop worrying and love AI agents. And for a lot of the time, well, not necessarily recently, but earlier this year, I was telling people to stop building agents, which is something we'll get to. And what I really meant by that was start with smaller types of systems and then start adding agentic capabilities. One of the reasons for this is a figure I like to show here, which I call kind of represents what I call proof of concept purgatory, where in traditional software development, excitement as a function of time starts off very small, right? And then it slowly increases. You start with a hello world, basic features, add unit tests, scale and optimize, load balance. And as these things happen, you're able to serve more and more end users and your product works. Things get more and more exciting. In absolute stark contrast to this, generative AI software development, super easy to get a flashy demo. And then you're like, wait, does it do what I think it does? Does it actually function for someone else? And it's like, well, maybe not. And then you start dealing with hallucinations. Then you've got so much complexity. You've got monitoring challenges. Then trying to integrate into your enterprise stack, for example, gets increasingly tough. So excitement goes down as a function of time. A lot of the work I do is help people essentially raise this red curve. I don't want to change traditional software development. I don't even want to change the amount of excitement you get with a flashy demo. But I want to help people raise this. Okay. Isaac introduced me, so I won't reintroduce myself. Just to say a bit about what we're here to talk about today. I just want to talk about what agents are. Then I really want to talk about what they actually are. Then I want to talk about why we should stop building them. Then I want to talk about how we can build them the right way. And then as part of my personal journey, I want to talk about how I learned to stop worrying and love them, right? So what are agents? So we all know what LLMs are. LLMs generate text, but can they take action? Can they actually do things? And LLMs alone cannot. But when we start to equip them with tool calls or function calls, they can. And essentially, this is what we're talking about when we're talking about agents: the ability to do things in the world. And we'll refine this provisional definition down a bit more soon. But we want them to be able to automate workflows and interact with external systems and perform calculations. We want them to be able to retrieve information. As you've seen in this course, we want them to be able to write and execute code. We want them to be able to use tools such as interact with email clients and calendars or image generators. We want them to be able to handle multi-step tasks. And we want them to be able to trigger action, so activate appropriate strategies, tools, or next steps based on context and inputs. Now, I think it's clear why we would want these systems to do these types of things. There's a meta point that if we think through like the amount of economic, societal, and personal value AI can generate, it seems clear to me that like 99.999% of the value they can generate will be through their ability to automate things, right? If we think about chat interfaces, the ability to have a conversation with an LLM is upper bound by human time in terms of reading and writing. And we all know how verbose they can be as well, right? And human time, of course, is one of our most precious resources. So the ability to automate is where a huge amount of the value will be seen. And we have a plethora of incredibly exciting tools, right? From Manus, which Manus has recently released, an email agent where you can tag it in emails to start doing things. Deep research. Some people may not think of deep research as agentic, but it definitively is. It uses a search tool, right, to go out and collect all different types of information. We've got Replit agents. We have Claude Code. And even if you think about the minimal version of Claude Code, which, you have a search tool and a bash tool, and like the amount of things you can already do with those two tools. We then have N8N, right? We have Cursor, which I presume a lot of you will be playing around with. Devon, Lovable. So there are all types of super interesting products in the space right now. A lot of which Cursor and a couple of the others I use daily, but a lot of these I use weekly. So this is from a user perspective, right? But I haven't told you from a builder's perspective what agents are. We've kind of hinted at it. So now I really want to dive in and see what really are agents. And it's worth stepping back a bit and thinking about what we call the agentic continuum or agentic spectrum now, because I don't think it's agent or no agent, right? There's a whole space of starting to become agentic. So LLMs themselves, when you ping an API, right? It's not like ChatGPT where there's some sort of memory already in the product. When you ping an API, there's no memory, okay? There's no tool calls. You can't do search or anything like that. There's no retrieval. You can't access any documentation. So immediately after you have an LLM, you want to start perhaps adding memory. You want to think about adding retrieval. You want to think about adding some tools, right? You may not though. So once again, I always encourage people to do some robust product thinking before starting to build. One of the most successful early LLM products was Honeycomb's text to honeycomb query language, right? And I mention that because there's no memory necessary in that in terms of having a multi-turn conversation. All it is one turn, natural language to honeycomb query. Okay, so that's really talking about going from LLMs to augment them with retrieval, tool calls, and memory. Then we start thinking about workflows where we start combining, pipelines of LLMs and those other things into larger systems. And then we can think about how this leads to agents. So I already mentioned all of these. Classic LLM, text in, text out. Then we want to read and write memory, have tools, retrieval. Now this figure, and some of what I'll talk about next is from a wonderful Anthropic blog post called Building Effective AI Agents from December last year, which I'm happy to share afterwards in Discord. But Anthropic then really spelt out what they saw happening in the space and what they saw their APIs being used for as well. So this is how we augment an LLM. In terms of workflows, before going totally agentic, what Anthropic saw is how much you can actually achieve with a few basic patterns, such as chaining. So you can have one LLM call, and then you can have a gate to see whether it passed or failed. And then you can have another LLM call and maybe a third, and then have output. And one example I'll give, and I can share a GitHub repository with all this code, but this is an example where you ingest LinkedIn profiles and automate outreach emails to prospective candidates. Because we all need more HR people reaching out to us all the time. Half joking there. But what happens here is step one, you extract structured data, such as name, title, company from a profile. Then you'll enrich it, and then you'll generate a personal outreach email. And these are 3 different LLM calls here, right? Now, what type of gate would be interested in there? We want to make sure it's structured data. We want to make sure we're getting JSON out, for example. So what you would do is have a test for if it's actually JSON or not. And if it isn't, give it a fail. If it is, pass it through to the next step, okay? Also, this very much helps with evaluation, right? And if you do want macro level evaluation, you do want to, in the end, know whether this helps with your business. Does it result in more great candidates hired who stick around more efficiently? But you want to tie it down to individual LLM calls as well. So you want to drill down and see if you did this in just one big like crew AI agentic system, it would be very difficult to inspect what's happening at each step, right? So breaking into steps can be very helpful in terms of evaluation. Another pattern Anthropic spoke about is routing, right? Where depending on the specific task, routing it to a different LLM. And this is once again an example from the recruitment email example where you would handle it differently, perhaps have a different type of email written or different prompts, that type of stuff. It's an if the profile is an executive as opposed to a recruiter. Perhaps if it's an executive, you want to get like more often get a human in the loop as well to make sure if it's, you know, high risk, high return, okay? The final one that they talk about, and there are a couple more, but these are really important patterns, is the evaluator optimizer, where we have an LLM making a call, providing a solution or response, and then another LLM evaluating it and either accepting it based on certain criteria or rejecting it and giving feedback. And in this example, you could have an LLM evaluating the quality of the email generated, okay? And what you'll see, and this is actually in some of the examples in the repository, what you'll see is that an LLM, if you give it a relatively good prompt, doesn't need to be super sophisticated as an evaluator, it will say things like, hey, you said, please reply if you're interested in a chat. And the evaluator LLM will say, instead, send your Calendly link with available options or suggest times for a call and that type of stuff. So reducing friction for the end user. So you see immediate returns with these types of basic loops. Of course, you do want humans in the loop and even subject matter experts to help craft these prompts. Who better than the person who wrote the emails to sit down and help craft these prompts, right? So we've talked about augmented LLMs. We've talked about workflows. What are agents? So these are 3 different ways which end up being pretty much the same. This is from Anthropic's, the same post. Agents are programs where LLM outputs control the workflow, right? Here, agents are systems where LLMs dynamically direct their own processes using tool usage, right? And this is something similar from Eugene. So the basic idea there is, in a workflow, the developer specifies the tools that are used. including perhaps send email, whereas an agent, the LLM output would decide it. And I'll show an example later, but when I say to ChatGPT, create an image for me or find out some information from me, the people who built ChatGPT didn't hard code, if so-and-so says create an image, use DALL-E 3 as their LLM output, which dictates that DALL-E 3 is the tool that is used. Similarly, if I say, what happened, tell me the news on October 15, 2025, ChatGPT will use a search tool because that's after its cutoff date, right? Nobody told it to, but its output triggers that particular tool. So that's the difference between agentic and workflows there. So little meme from Hugging Face, agents, wait, it's just a for loop, always have been, always has been. So just to think through when to use an LLM, when to use an augmented LLM, or when to use an agent. If you want to merely generate text, use an LLM. If you want to retrieve external information, use APIs and tools, have predefined multi-step tasks, use an augmented LLM. If you want LLM-controlled multi-step tasks or to adapt the workflow dynamically, use an agent, right? I would argue that this happens very rarely when you're building software that you want to serve reliably and consistently to external end users. Key takeaway, if a simple tool call works, don't build an agent. So just thinking through the type of failure modes that happen. So this is an agent I built for my own use where I wanted to build a data science, data analyst agent, SQL query tool, data analysis tool using Pandas, data viz tool using Matplotlib and Seaborn, right? And what type of failure modes do we see when we start adding more complexity? We immediately see observability issues, right? It's harder to inspect our system and see what's happening inside it. We get brittle systems, right? Where even a slight change to a prompt or the same prompt can result in very different results. We get complexity creep, right? And we don't even understand quite what's happening. And I mean, when you use, Claude Code, or you hook up to an MCP server with 90 tools, right? That can be really challenging in understanding what's happening. It can be incredibly powerful when you have a human in the loop, which we'll get to, right? You also get misaligned autonomy where they just go and, I mean, we've all had this, right? Where they just do all types of stuff all the time, such as, you'll tell it consistently to not write code yet, and it will just start writing code. Or you'll say, make sure to write a small script, maximum 80 lines or something, and it could even create a subdirectory with 3 scripts inside it, right? They're getting better at that. Devon has always been a monster for me. I did want to present an alternative, though. I think I wouldn't be doing my job if I didn't talk about multi-agentic systems, which I think can be incredibly powerful. But when we do want to build reliable software, they can be incredibly challenging. So we've got our LangGraphs and Burrs and small agents and Crew AI. And I just want to show you something that I built in Crew AI. I'm not going to go through the whole thing, but what I built was a research crew that would research it would be a comparison research crew for 2 different topics and compare them. And I'll actually just tell you what I did was I compared LangGraph and Crew AI and asked it to find the best framework for building agents in 2025. I just want to show you what I did here. I got it to search the web with SERPA dev tool, to search for item 1, then to search for item 2, and then finally to search for comparison. So it should be doing 3 tool calls there. Then I did the same using Tavily search tool, so we'd expect another 3 tool calls. Then I asked it to do the same with Reddit Tavily search tool, so we would expect 3 more tool calls. So in total, we'd expect 9 tool calls there. And then I asked for a list of 10 bullet points summarizing blah, blah, blah. Then I ran it. And I just want to show you the span graph of what I got out. So this is on going left to right, we've got time. Then we have everything that's happening in the system. Not only, I mean, Crew AI is incredible. When I first used it, I didn't even know it was using light LLM, right? So the abstraction layer is definitely too high for me. But what we actually see here How many tool calls do we have? We have 1 tool usage, 2, 3, 4. I asked for 9, right? There are ways to improve it slightly, but the point remains is we talk about hallucination a lot. We don't talk about forgetting enough. And I ran this 100 times, and not once did I see 9 tool calls used. I think the median was 5, and it ranged between 3 and 7, something along those lines, right? So that's all to say, when you're building these systems, particularly using tools, using frameworks like this, a lot of things that you don't want can happen, and then the inspecting them is incredibly tough. Seeing the prompt that's even sent to your LLM with Crew AI is really tough. And of course, as some of you may know, Hamel wrote a post called "FU Show Me the Prompt," and I'm not saying the cuss word because this might be uploaded to YouTube and the YouTube algorithm penalizes cuss words occasionally. I found out the hard way. But part of Hamel's post essentially was when you're using even RAG frameworks, Llama Index, whatever it may be, actually finding what prompt is sent to the LLM can be tough. And Hamel actually created a tool to intercept the prompt call in order to see it. So slightly being intentionally a bit provocative here. This is another version of my table before. Should you use an agent? Probably not. If you need text, use an LLM. If you need to interact with tools and APIs, ask the question, do you need the system to control the workflow dynamically? If the answer is no, use an augmented LLM. If the answer is yes, use an agent. And half tongue in cheek, I say this is rare, experimental, and extremely dangerous. I would take out the rare now, and it is dangerous unless you have strong supervision and a human in the loop, which I'm going to get to in a minute, okay? Before that, though, I just want to say a few words about how we think about building AI-powered software the right way. And I actually have a Maven course, which Julian joined the last cohort of, where, I mean, it focuses on a lot of this, but really thinking about building it the right way. And what it means is having evaluation and observability from day one. That doesn't mean like super hardcore evals and all of that from day one, but having a sense of how to use evaluation to guide product development and software development. Having definitions of success as early as possible, and having robust logging and metrics from day 0. So, as Hamel wrote in this wonderful blog post, the 3 things you need are processes and tools for 1, evaluating quality, such as tests, 2, debugging issues, such as logging and inspecting data, and 3, changing the behavior of a system, prompt engineering, fine-tuning, writing code, embeddings, chunking, OCR, whatever it is. And too many people focus on 3, whereas 1 and 2 are essential. So just thinking a bit through how we do this, agentic or otherwise, when you build an MVP, you can either generate synthetic data yourself, or you can get some user queries, roll it out internally, or roll it out to a handful of users. Then label the responses by hand. Put them in a spreadsheet, or put them in a data viewer, vibe code a data viewer that resembles your user interface, right? There are lots of ways to do this. Just take 20 examples and give them a pass or fail, give them a reason why, and you use this labeled data to build a basic, what we call an evaluation harness, which is really this test set and some sort of script, which when you switch out the model, will tell you how well your new system performs. You use this minimum viable eval harness to evaluate and improve your MVP and keep going. Now, this isn't new. A lot of the implementation details are more complex because of the nature of LLMs and AI, but this type of evaluation-driven development is what we've been doing in machine learning for years, where you have an MVP, collect data, label responses by hand, you build a test set out of this. Your test set is really your eval system with traditional trad ML, as we call it. And then you use this test set to evaluate and improve your MVP. The types of things you want to be evaluating are cost and accuracy, latency, and user business metrics to start. And by accuracy, F1 score, precision recall, whatever's important to you. I do think too many engineers focus on, LLM call metrics and don't tie them to larger business metrics as much as we should. So making sure these are there is super important. And then when you change your system, you can take your new AI system response and compare it with your ground truth, right? Which are your samples with labels. You can use an LLM as a judge. You can use structured outputs. In the JSON example before, you don't need an LLM as a judge to tell whether the output was JSON. You can test for structured output, right? You can use PyTest for that. String matching, fuzzy matching, regular expressions, all of these things will get you a long way. To be able to do this, you need logging, right? So on the user end, system prompts, user prompts, whatever it may be. On the LLM API, you want to log response output, structured, unstructured, tokens used, function calls, retrieval, these types of things, errors, latency cost, and so on. So that's just a little flavor of kind of a way to think about starting to build this type of software powered by LLMs. So to wrap up, I want to tell you about how I actually learned. This seems like an anti-agent talk, and yet I told you at the start that I use agents daily. And I reflected on that. I was like, why do I tell people to stop building agents when I use them all the time? So this is a post I wrote called Stop Building AI Agents, and I'm happy to link to that. And yet, here is me saying I use AI agents every day. And in fact, to create this image, I used an AI agent. I put my headshot into ChatGPT and said, hey, this is my headshot. Can you create a cartoon version of me? In the style of Studio Ghibli, saying I use AI agents every day, right? And that is along the agentic spectrum. Nobody told it to use that tool. It was triggered by my input and the output of the LLM. I've hinted towards this throughout this talk, but when I sat down and really reflected on this, I realized that when I'm telling people to not build agents, a lot of the time, it's in the case where you don't have a serious human in the loop, right? Where expectations are set. And so, cursor in what used to be called YOLO mode and unsupervised Devon, where you have high agency, low supervision. Or if you're booking.com, right, and you have a travel assistant agent, you can't expect high supervision from every user, and you wouldn't want to do that. You don't want to get tool calls wrong there. When you have high supervision, as in when you and I use cursor, not in YOLO mode, right? That type of supervision, a tool call can happen incorrectly, as it often does, right? So when we have AI as collaborators, I think where you have a high AI agency and strong supervision with a human in the loop, which is what you've been doing in this course, that's a really wonderful time to use agentic systems and also to build agentic systems. So I do think in several ways, there are two cultures of AI app development. There's one in which we're trying to build robust, consistent, reliable software. And in another, this is part of the huge increase in surface area of what's possible with software, right? We're building systems which aren't consistent. They aren't necessarily reliable, and yet they deliver incredible value because we use them as collaborators and thought partners where we're strongly supervising them. Yeah. And to that point, I told you Anthropic was telling people start small, start with workflows. And yet, 7 months after they published that now seminal blog post, they published a post on how we built our multi-agent research system, which I encourage everyone to check out. It's actually an incredible post because they have their main agent spawning sub-agents on certain tasks, then feeding information back to the main agent that then spawns further sub-agents. And not only is it so much complexity creep, but they actually talk through some principles of how they think about evaluation, how they think about prompting, how they've actually discovered that they can build some, with an injection of domain human expertise, some of their agentic systems can be self-healing and repair prompts themselves if they have an explicit failure mode given and those types of things. So I do want to end by saying, I've told you I use agents all the time, and there are just so many different types of agents I use, and I've seen people use successfully. And we're seeing the levels increase so much and the capabilities increase. So remember, 2 years ago, we were copying copying and pasting from ChatGPT when it didn't even know its own API. It was great with the PyData stack, but it didn't even know its own API. Even if you told it its own API, it would revert to the previous one, right? Um, and then we had like code completion, and then we had AI assistants in Cursor where you have a chat and it like writes code and that type of stuff. Now we're seeing embedded agents in Slack and Discord and email. I mean, Isaac, you mentioned an example to me a couple of weeks ago of someone who has Devon or Cursor in Slack and they ping it to edit documentation. Um, then we're seeing more and more reactive agents, such as ones that will do code review in continuous integration or GitHub Actions and these types of things. In this course, you've learned a bunch about background and ambient agents that you can go and let do their thing, and then they come back. Um, what we're going to see more and more of, it's very nascent though, is proactive AI. So agents that notice stuff in production and come to me on a Monday morning and say, "Hey, look at these patterns. Maybe we want to make these changes." And these are the types of things that we're seeing first in software development. But we're going to see all throughout. I mean, I don't think it's that too distant future where we have proactive AI agents that will come to executives and say, "Hey, these are the emails you got over the weekend. These ones are priority one and two. Your Monday afternoon's full on your calendar. I can shift these meetings so you can get this time for deep work to work on this thing." I know that seems like a somewhat futuristic, but I think with the correct human in the loop structures, which we're seeing emerge now, and the correct supervision, it's not that far off. So what are the takeaways here? Um, because there are two cultures, there are kind of two types of takeaways. The first is when building, for the most part, start small. Use augmented LLMs and workflows first, then introduce a few tools as needed and scope your product down as well to see if you can build something that solves a business problem with a select set of tools. Only then move to agents. Fundamental observability and evaluation are key. But then the other side of the culture is don't be afraid to build complex agents when there's strong supervision. So that's building things for yourself, for your teams, or at the moment for software developers, such as people using the types of tools you're learning about in this course. Um, I think that's it from me. I yeah, I hope that was instructive, and I'd love to answer any questions you may all have.
Yeah, we do have some questions. This was fantastic. I have lots of my own questions, so I'll just make a comment and then I'll let other people ask questions and I'll come back to mine after that. But yeah, I think the observability is particularly interesting because that's a case I think that and like understanding what's going on with these applications. I think that's a place where it really shows how these agents can be limited. They can do so much. You can do so much with LLM tool calls and agentic loops and have so much agency and so much power. And yet, like the key to improving an LLM system is to like look at a trace manually and take notes. It's like it just you still have to like go back to and it can do so much, but and yet we're still at that place where like our best tool is looking at these manually. And I think that to me always illustrates like why you can't always just reach for an agent or reach for something and assume it's going to fix all your problems. Um, so we've got a question from Julian. I'll read it out. And then, if you'd like to, follow up and ask, you can follow up in Discord or you can just unmute. The question is, would you consider this failure case of an LLM not fully following instructions, asking too much on a single prompt rather than splitting into multiple calls? And I think this was related to when you were asking for 9 tool calls and it wasn't doing all 9. Um,
You hit the nail on the
was
head, Julian. You absolutely hit the nail on the head. And so splitting up. So I'll actually speak to a slightly different example because it'll be more obvious here. But in the like extracting JSON of structured data from a LinkedIn profile, as I said, you'll want name, title, company, um, job history, skills, something like that, right? Or maybe recommendations or references. Now, if you do that in a single call and ask for structured output, you will get forgetfulness. You'll get some hallucinations sometimes as well, and errors in certain fields, depending how many fields you ask for. Whereas if you parallelize it, right, where you have one LLM call asking for name, one for title, one for skills, and so on, then you'll get far higher accuracy a lot of the time. Now, the challenge there is it's increased cost because you have a bunch of different calls, and you can parallelize smartly to reduce latency, but a lot of time you'll get increased latency as well. So splitting into multiple calls is a wonderful idea a lot of the time. It isn't always cost and time effective, but yes, absolutely. But in that case as well, I think with respect to your question, you'd kind of be telling it you have to do all these calls, and you're kind of creating parallel workflows then, something not even agentic, right? In that particular case. I hope that's
Yeah, and
helpful.
that's interesting. I think that kind of gets to the point of like you had this example earlier where you said you can create a workflow by saying like, hey, if this is an executive, use this template or send this email. If this is a recruiter, send this one. And how do you think about when do you switch from that? Because like you could say like, oh, well, now if it's an engineer, then do this, and if it's a data scientist, then do this, and if it's a marketing, like when do you kind of think about switching from continuously like adding to the if statement versus doing something more agentic?
Mm, it's a great question. And I do think initially it's how strong a human in the loop um, you want there to be and can afford. And then your appetite for risk, right? So perhaps if you're serving ads to different types of consumers, you may not care so much about the risk of serving the wrong ad to the wrong person. Or I would argue that society takes on certain risks with that as well, right? Whereas if you're serving, if you're an if you have an online pharmacy that's delivering prescriptions to people, you probably don't want to take on that agentic risk as well. So I think the two questions are how strong a human in the loop do you have, and how risky is your situation? But once again, most of the time, start small, and if it is blowing out, then perhaps create something agentic or agentic.
All right, great. So next question, how do you implement observability in high privacy regulated environments? Um, there's some discussion going on about there's lots of anonymization methods. Regulated areas typically define what methods are acceptable for their domain. Um,
I mean, yeah, this is
yeah.
a great question, and the way I'd actually think about that is prior to even introducing LLMs, how do you think about privacy? How do you think about anonymization? Do you use differential privacy techniques already? If so, are they applicable here? I do think having customer interactions that require privacy introduce additional questions here, but a lot of the time in organizations, you've figured out a lot of these things, and they're principles that you can then apply at the observability LLM layer as well.
All right, great. And anyone that's asking questions, feel free to unmute at any point at this as well. It looks like there's some questions being typed. I'm going to go ahead and plug a course that I'm excited for that's coming up, which is Hugo's course. So if anyone's interested more in building this, I know an hour is not a whole lot of time to learn how to build an LLM application, even if you're only talking about agents or only talking about workflows. There's like a whole spectrum as he's been talking about and how to build incrementally. So that's a course that I'm going to be signing up for to take myself, and I hope that all of you join. Do we have a link to your course we can
Yeah,
share?
we do. And I have a little, now that you mentioned, I have a little plug for it as well. Um, Starts in November. It's for 4 weeks, and it's 2 2-hour workshops each week. We have Q&As with expert practitioners. And I was going to invite, we're doing a lightning lesson and workshop next week, Isaac, but I was going to invite you to come and give a talk there as well. But we
I
have,
would love
people
to.
like Samuel Colvin from Pydantic, and Jeff Huber from Chroma, and Ravan Kumar from DeepMind, and a whole bunch of cool people. Lots of credits as well. And I'd just love to offer your community 25% off as well, Isaac. So let me find that link. Um, and I
All right,
I
I
don't.
just typed that bit.ly in,
Oh, great.
bit.ly link in manually, so I got the link from that. So that's great.
Awesome. And I do want to say,
Old-fashioned way.
yeah, this
Oh,
this may
that's a
be
huge discount. Holy crap. Okay, that's great. Yeah, don't sleep on
um,
that.
totally. And I do want to say, I don't want to, you know, put him in the line of fire, but Julian was one of the most wonderful students and community members in the last cohort, and I think he'd have positive things to say about it. But if you do want to chat with Julian at any point to see whether it'll be an appropriate course for you, I'm sure Julian might be happy to chat with you to let you know or send you a message.
Yeah, absolutely.
Appreciate you,
Great.
man.
Um,
Um,
so there must be many cases where human in the loop is required. In my opinion, in this kind of situation, it's important for the front end and the back end to share the same state. Since you've likely seen many projects, what front end packages are typically used in practice, such as Copilot Kit? Um, I'm not sure I'm following the question completely.
yeah, I'm not either. Whoever asked it, could you turn your microphone on? We can just chat briefly.
Yeah, thanks. I'd like to ask question about, you know, for example, when we the build agent with LangGraph, uh, it is important to the check and use the state of agent, right? So when building the agent, uh, it is important to share the state of agent between front and the back end. So that
So
is
do you
the
mean
question of mine.
Would you give an
you
example application?
Uh, mm,
do you mean like in a chat application, how like you might have three or four turns going back and forth, how you want the prior chat history to be displayed on the front end while you're still sending the full history to the LLM on the back end? Is that kind of the thing you mean? Or am I misunderstanding?
mm, and I mean, not the chat history, uh, the kind of the state that is for the AI service that we are trying to build. So for example, uh if one of the using if one of the in the human in the loop, we kind of the setting the approval from the client. So if the human allow to the something the agent action, the chat the front, which is the running from the back end, they should know the human approved something.
Yeah, so in cursor, for example, or whatever it may be, when I have it in safe mode or whatever it is, like it will say, I've edited this file and I need to accept or reject it. Is that an example?
Yeah.
Yeah, yeah. I mean, absolutely. That's essential. In a lot, I mean, in software development and for AI assisted coding, you definitely need that. For a lot of AI and agentic applications, you actually don't want that level of interactivity with users, right? You want to keep it far more simple.
Okay, thanks.
All right, great. Robin, did you have a question?
Yeah, thank you very much for the info so far. This has been very informative. So, in this pattern of like, instead of building an agent, define a well-constructed for loop or, iterate some number of times. Like, I'm curious how much additional context you think about padding into the context going into the agent in each successive like iteration of this loop. Like if you're either doing, the LLM evaluator, are you then passing back into the second attempt of this loop like you have already tried X and failed, or like any kind of additional context that can be gained by each additional step of the loop if you're trying to iterate over something, 10 different times and get 10 results?
Such a wonderful question. I'm going to answer it in a couple of ways. The first way I want to answer it is there isn't a one size fits all, but you can use evaluation, evals or robust evals, or even vibing or otherwise to guide your prompt iteration and your application development. So you'll see it come out as you iterate on prompts. One will often work better, and if you do have some basic eval harness set up, you'll be able to measure which works better in your particular case. The other way to think about it is, firstly, start simple, and so don't give the previous state as essentially to the optimizer. Don't say it's your second pass. I'm sorry. You perhaps return what it wrote and say, here's the feedback, and here are some suggestions for how to improve it. And often that works very well. If you're still not getting the performance you need, then add a bit more complexity and a bit more context. And this is in the spirit of, we've got all types of, conversations around infinite context, and we're told how long context windows are, but they are technically that long, but for all intents and purposes, they're not. I'll actually recommend ChromaDB and Jeff Huber's work on context rot, among other people, that for all intents and purposes, the context windows aren't what you think they are. So I still think keeping context small and keeping what you give each LLM specific and relevant is super important. So start small and add as necessary. Does that help?
Yeah, it does help. Just like, a quick example of a thing that I've kind of struggled with trying to do in the past is like, let's just say we have an agent that is going to make news queries, and we're going to pull articles and we want to get 100 articles about a specific topic. I just kind of seen this thing of like where stochastic, a tool call might have some stochastic number of results coming back. And it can be hard to kind of like, even in a for loop, to kind of get it to come up with enough variance of the queries being passed into, this tool to be able to kind of get the coverage needed. So that's the pattern that I've encountered, where then it does start to seem to be more needed to just pass in additional context to kind of bust the pattern.
Yeah, I love that. And that would be a case in which I say perhaps embrace the complexity of not necessarily being able to inspect everything. Because in that case, you're not necessarily trying to build robust, reliable software to serve to consumers. You may be, but if we think about analyst agents and research agents, we kind of want them to go out and do all types of wild things and come back to us with information we can potentially synthesize as well. So you do potentially have strong supervision there. The other thing is this, a lot of the work I do and the course we teach is about how to tame the non-determinism or stochasticity, or the different outputs you get from LLMs and agentic software. But in this case, the non-determinism can kind of be a superpower. Like if you sent out 10 research analysts, you want them to come back with different ideas and different results, right? So in that particular case, I actually think you may not need this. This may not be as much of a concern.
Okay, thank you.
For sure.
Anyone else have questions, comments?
If not, I have a comment. And I'm just trying to find if I can find this post. Oh, I clearly can't. Let me. Oh yeah, got it. So I actually spoke with Brian Bischoff from Theory Ventures. If you don't know Brian, definitely follow this guy on where at LinkedIn, whatever. He's someone who I learned so much from about the space, and he wrote this blog post, and we chatted about it recently on my Vanishing Gradients podcast. And this is actually, well, Hamill posted this, but But Brian asked a question. He was like, yeah, like we do want to build small and be able to like inspect our systems. And then he was like, but if we build more complex stuff, it's also so powerful, but we also want it to be reliable sometimes. So how do we think about bridging these two different cultures? Those weren't quite his terms. But he came up with the idea. I mean, like me, his background's in mathematics. He came up with the idea of using transition matrices, which I'll explain in a second, but which you can see here, to think about what he calls failure as a funnel and identifying, um, how to use failure as a funnel and evaluation to guide development to see what tools are failing the most. And so, if you have a whole bunch of these states for your system, you've got a decide tool, generate SQL, execute SQL, and so forth. Then so these are states. These are also states. If you going down, you have the state it's going from. Across, you've got the state it's going to. And if you have enough runs of your system to be able to count where failures occur and then plot it like this as a transition matrix, so transitioning from this state to this state, this is looking at your data, but in a slightly more sophisticated way when you have all these different tool calls. What you see is that most of the failures here, 12 of them, occurred going from generate SQL to execute SQL. So it hasn't been executing the correct SQL, right? So this is one burgeoning way of thinking about how to look at your data and explore your data when building more sophisticated agentic software as well. So that's my comment about my talk.
Cool. Any other questions? Things people have struggled with? Just apps they've been building and how they've been thinking about incorporating LLMs or agentic loops, or whether it's like a solo build or a hobby project or an enterprise project. We've got a few minutes so you can get some free coaching in.
While we're waiting on a lot of the blog posts I mentioned, I'm just pasting here as well in the Discord.
I have a question. Can you hear me?
Yeah.
Yep, we can hear you.
Okay, good. So, have any of the recent changes, let's say, in the past few months on agentic tools, did you change your mind on some aspect of using agentic tools, or
Yeah, totally.
or the way that you think about agents, or I don't know,
Absolutely.
maybe
The
new
new models.
ideas?
Yeah, the new models and like 4.5, for example, the new models seem to be far better at getting tool calls correct. So I'm definitely more bullish than I have been on the ability of these models to do the right job. I do think, once again, when trying to build reliable software, you can't just YOLO it, and so you do need to reduce complexity and have evaluation and that type of stuff baked in. But yes, I think increasing contexts, smarter models, ability to execute tools better, these types of things are incredibly powerful.
Yeah, and what about the smaller models getting better, like making gigantic leaps for models that you can run locally and even maybe fine tune for your use case, just for like less cost, privacy, more control, whatever.
Absolutely. I
Where
love
do you
it, man.
see that moving forward in the near future?
Yeah, it's a great question, and I think it depends. At the moment, a lot of people kind of want to use LLMs that can be multi-purpose in a lot of ways, right? And smaller models, there are lots of fantastic smaller models out there and open weight models. They're just not as good, right? So people do want to use the state of the art. Having said that, if you've got like an AI software pipeline that performs intent classification on a user query before doing a bunch of other things, definitely use a smaller model. You may even use a classic NLP model there. Or, there are all types of things you could do there. When building an LLM as a judge, you can definitely use smaller models, but sometimes just using regular expressions or fuzzy matching or that type of stuff can be super powerful. I also think, and I can link to this, I recently did a workshop, a live stream workshop on fine tuning. Maybe you were there. I can't remember, with Ravin from DeepMind on a model him and his team built. Gemma 270 million.
Yeah.
270 million, not billion. Okay. And we fine-tuned that for a variety of cases. And one case was actually to generate NPC game character language to sound like aliens, for on-device stuff. So, for on-device things, having smaller models is incredibly powerful. A lot of the time with that case, you can prompt your way around that, but then that's hackable. Once you fine-tune, it's far more set in stone, so users can't essentially, red team you out of it. But yeah, I think for a lot of enterprise applications, people are still really bullish on big lab models. There's also a marketing incentive to use these big like, who doesn't want to be using the new Anthropic model? Like, if you're not using the new Anthropic model, like, are you really, on top of it? So there's like yeah, social signaling there as well, which I find fascinating.
Yeah.
There is another
All right,
question that
go ahead.
So JP has asked, what agent framework would you recommend starting out with? I would recommend starting out with an LLM call, adding memory. You want adding some tool calls, adding some retrieval if need be. Start adding some workflows, and then moving from there. If you really want to use an agent framework, I think use any one of them and get burnt like all of us did in the end. That's if you're wanting to build like reliable, consistent software that you can inspect. But if you don't, they're all super fun. I think I probably do have a small preference for small agents from Hugging Face. But yeah, play around with them all. But I would encourage you to start building small as well.
And OpenHands just released a new agent SDK, I think, within the last week or something like that. So if you want to roll the dice and have fun with something brand new, you can try that.
Yeah.
All right. Well, I think we're just about out of time here. So thank you all for coming. This is the last day of my course, so thank you all for coming. And to that, I'll be around in the Discord in our course this whole time. I hope I see you in Hugo's discourse in his new course soon. That starts in like what, a week and a half, something like that.
On November 3rd US time, which is November 4 where I am, APAC in Australia. And I did mention chat with Julian if you want to hear more about the course, and he mentioned to do so in Discord. Of course, I forgot to mention, let me know if you have any questions. Don't just come as well. So feel free to ping me in Discord as well. Always happy to chat and happy to help. I love this stuff.
All right, great. All right, thanks everybody. We'll end it here for the day, and yeah, we'll keep the discussion going in Discord.
Thanks once again, Isaac.
Yeah, thank you, Hugo. This was great.
Bye.
See everyone.